Your critique raises several common objections to intelligent design, ID, which merit thoughtful responses. Let's address these point by point to clarify the nature of ID and the standards it strives to meet within the scientific community. 1. Rigorous scientific methodology. You argue that ID lacks rigorous scientific methodology, particularly in the realms of irreducible complexity and specified complexity. However, proponents of ID do employ scientific methodologies to explore these concepts. For example, the irreducible complexity of the bacterial flagellum has been studied not merely as a static artifact, but through genetic knockout experiments, where researchers remove or alter genes to see if the flagellum can still function. This is a direct, experimental approach to test the hypothesis that certain systems require all their components to function, aligning with scientific methodologies that test for functional dependencies. 2. Bias and scientific method. It's true that every scientist has biases. ID proponents, like all researchers, must strive to objectively test their hypotheses. The key distinction you've highlighted is that ID starts with a conclusion. However, it's important to note that many scientific theories begin with an intuition or hypothesis about how the world works, which is then rigorously tested. The difference with ID is that it considers an intelligent cause as a plausible explanation for observed phenomena, which is then subjected to testing against naturalistic explanations. This isn't inherently unscientific. Rather, it's a different starting point for hypothesis generation. 3. Empirical evidence and experimentation. The claim that ID lacks testable hypotheses and relies on inference is not entirely accurate. ID does propose testable predictions, such as the expectation that certain biological information, like the digital information in DNA and complex molecular machines, will not be explainable purely by undirected processes like natural selection. These are indeed based on inference, but so are many scientific theories that infer unseen phenomena, like dark matter or historical evolutionary events. What is crucial is whether these inferences lead to predictions that can be empirically tested, which ID proponents argue is the case. 4. Gaps in evolutionary theory. While it's true that pointing out gaps in evolutionary theory does not constitute a positive argument for ID, these gaps are relevant in assessing the sufficiency of naturalistic explanations. If evolutionary mechanisms are shown to be insufficient in certain respects, alternative explanations, including ID, gain credence. However, ID also offers its own positive arguments based on the complexity and information content of biological systems. 5. Validity and evidence. The assertion that ID is not valid because it is more philosophical than scientific overlooks the fact that all scientific theories have philosophical underpinnings, including assumptions about the nature of reality and what constitutes an explanation. The critical factor is whether ID's hypotheses lead to testable predictions and are supported by empirical evidence. The debate over whether ID has met these criteria is ongoing. Conclusion. The portrayal of ID as either a legitimate scientific theory or as pseudoscience depends significantly on the criteria used to judge its validity. While ID does face challenges in gaining wider acceptance in the scientific community, it is not accurate